Today we're giving the BMW R25 some well-deserved attention by rebuilding its final drive. Inside this housing, a precise set of gears transfers power to the rear wheel, but after 74 years, the original gears have suffered heavy wear and chipped teeth. In this video, we'll go through the complete restoration process, bringing this final drive back to life with a new set of gears. So stick around and let's get started. In front of me is a brand new ring gear welded directly to the splined output shaft. The ring gear ratio of this final drive is 27:6, meaning the ring gear has exactly 27 teeth, while the pinion only has 6. At the top, there's a seat for a small radial ball bearing, and over here, I've got a new one. On the opposite side, you'll find the drive spline, which directly powers the rear wheel. Above that, there are two machined seats, a smaller one for a shaft seal, and a larger one for a large diameter radial ball bearing. I also have a new bearing for this side, which will be installed at this height. Inside the housing, there is a machined seat for a felt seal, held in place by a small cover. I'll be assembling this later on in the video, so don't you worry. The first component I'll install is the large fog bearing, using an arbor press and a set of spacers to bridge the splined shaft. For now, this is the only part I'll add to the output shaft so that the gear can be properly shimmed within the housing. Speaking of shims, I have a selection that came from two different final drives. While taking a closer look at them, you can clearly see a burr on them. These were originally installed like this, but they shouldn't have been. So I'll clean up the edges with a file to add a slight chamfer to them. This will allow me to stack them correctly during the assembly process, making them true to size when measured. To install the ring gear, I'll heat the housing to around 70 degrees Celsius using a heat gun. A shim is selected, then the ring gear and its ball bearing should slide right in without any issues. Holding it in place for a few seconds helps seat the bearing, and it's always a good idea to check for smooth rotation after assembly. Next, we'll focus on the 6-tooth pinion gear and install a new roller bearing. The inner race of the bearing is pressed onto the pinion shaft using an arbor press. This bearing has a separate outer race which must be inserted into the final drive housing. To make the installation easier, I'm using a step disc tool and heating the housing to about 70 degrees Celsius once again. The heat will expand the housing, allowing me to install the outer race without any issues. As you can see, the pinion is now centered and supported within the housing. Now things might get a little bit technical from here on because BMW updated the pinion assembly between 1951 and 1952. Let me explain. What you're looking at here is the first version of the BMW R25 pinion setup. It features a pinion shaft with a roller bearing towards the gear, a sleeve behind that, and a double angular ball bearing. Notice the tapered surface on the pinion shaft towards the middle. This is important to remember. Sometime between 1951 and 1952, BMW made a change to the shaft portion of the pinion gear. They added a step and introduced an additional part. The new setup includes a roller bearing close to the pinion gear, a shorter sleeve, a shim, and again, a double angular ball bearing. You can see the difference in the sleeve height here and how the shim compensates for that change. This small modification helped separate the loads between the double angular ball bearing and the roller bearing. Here are two drawings from the factory manual to show you this change in detail. Feel free to pause the video if you want a closer look and a better understanding. For this assembly, I'll be updating the pinion parts by using a shim. First, I'll install the short sleeve, followed by the shim. As you can see, there is a clearance as the manual states, but it seems a bit too much. To measure this gap, I'll tighten the shim against the pinion shoulder using a spacer, washer, and a regular hex nut. Using a feeler gauge, it measures exactly 16 thousandths of an inch. This is twice the amount BMW recommends, so I'll need to find a solution. The left shim is a stock part available online, and the right one is a custom machined part designed to reduce the clearance with a step. With the step towards the sleeve, I can now measure the correct clearance, which is 8 thousandths of an inch. Now that's sorted, I'll install the double angular ball bearing into the bushing. This is then pressed onto the pinion shaft, completing the pinion assembly. To properly secure the pinion assembly within the final drive housing, a specialized nut, also referred to as a threaded ring, is threaded into place and tightened. This part plays a crucial role in keeping the pinion assembly securely seated. For this job, a special tool is used. It's designed to fit precisely into the nut, ensuring a firm grip for proper tightening. When adjusting the pinion gear, precision is key, and this is where shims come into play. A shim is placed flush against the face of the roller bearing. Once the pinion assembly is installed, this shim sits between the roller bearing and the pinion bushing. Then the threaded ring is tightened down, locking everything securely in place. For a quick understanding, these two gears are shimmed to ensure proper gear meshing. To achieve this, we adjust the gears using shims either by increasing or decreasing their thickness. This affects the distance between the gears, bringing them closer together or farther apart, while also ensuring the correct positioning of the meshing. To determine how well the gears are meshing, I'll apply a gear marking compound evenly across 5 teeth of the ring gear. As I rotate the pinion gear, the compound transfers onto the pinion and spreads across the remaining ring gear teeth. This creates a visible contact pattern showing precisely where the pinion gear makes contact with the ring gear. Upon inspection, the pattern reveals that the pinion is engaging only toward the ends of the ring gear teeth on both the drive side and the coast side. This indicates that an adjustment is necessary. To correct this, both gears must be removed. The housing is gently heated to allow for safe removal, and additional shims are inserted to build a proper shim stack. This will refine the contact pattern and improve gear engagement. With the gears reinstalled, another layer of gear marking compound is applied to reassess the contact pattern. Right now, the gears are too tight and there's zero clearance between them. In this state, they would essentially grind themselves away over time. Before making any drastic changes, I take a closer look at the pattern. It's relatively centered, which is a good sign. Now, to fine-tune the setup, I'll swap in a slightly thinner shim under the ring gear bearing. This will increase the clearance and allow the gears to rotate smoothly without excessive wear. While achieving the correct gear meshing pattern is crucial, we also need to ensure the proper amount of backlash between the gears. This clearance is essential for smooth operation and longevity. For this task, I'll be using a few specialty tools that I made in-house. The first tool is a rod that threads to one of the housing studs. This provides a solid mounting point for the dial gauge, ensuring stability during the measurement. Next, I need to prevent the pinion shaft from rotating. To do this, I've fabricated a custom locking plate that securely holds the pinion in place. The final tool is a ring gear extension with an attached arm. This allows the dial gauge to make precise contact and provide an accurate reading. For the most reliable measurement, the dial gauge must be positioned at the center height of the ring gear teeth, exactly where they mesh with the pinion gear. Additionally, the gauge must be perfectly square to the arm of the specialty tool to avoid any skewed readings. With everything set up, we can now take a measurement by rotating the ring gear back and forth. The dial gauge shows a backlash of 7 thousandths of an inch, which is well within the specified range. If the backlash were too small, I would reduce the shim thickness under the ring gear, lowering it slightly to increase the clearance. If the backlash were too large, I would add more shims, bringing the ring gear closer to the pinion. It's important to note that the backlash should only be adjusted once the meshing pattern is within the acceptable range. Once everything checks out, the gears can be removed, and any remaining marking compound can be cleaned off using paint thinner or mineral spirits. The next step is to install all seals, starting with the felt seal and its cover. Before installation, the felt seal must be fully saturated with gear oil. This ensures proper lubrication and prevents it from drying out. Once the seal is thoroughly soaked, it's placed inside the cover and then carefully pressed into the output shaft. Next, a new shaft seal is installed into the final drive housing, ensuring a tight fit to prevent leaks. Finally, the pinion seal is installed into the threaded ring, completing all seal installations. The ring gear will now receive its top radial bearing, which supports the opposite end of the shaft. Once the bearing is pressed into place, the ring gear can be installed into the housing for the final time, using the selected shims to ensure proper positioning. Before installation, I'll wrap a layer of tape around the output shaft spline to protect the freshly installed lip seal from any damage. Applying a bit of heat to the housing allows the ring gear to drop in smoothly with minimal force. Next, the pinion assembly along with its selected shims is installed. This is followed by threading in the locking ring to secure everything in place. Although the inside diameter houses a seal, I'll apply a flange sealant to the threads of the locking ring to prevent any future leaks. Finally, using the specialty tool, I'll tighten the locking ring securely, fully locking the pinion assembly into place. Before sealing the final drive with the cover, a gasket is used to ensure a proper seal, along with a shim to keep the output shaft correctly positioned. This requires taking a few precise measurements to determine the correct shim thickness. The first measurement is taken from the housing's gasket surface to the top of the radial ball bearing. The second measurement is taken from the cover's gasket surface to the machined face of the bearing seat. Additionally, the thickness of the gasket itself is factored into the calculation. Once these values are recorded, they are subtracted from each other, giving us a clearance value, and this value is D. According to the workshop manual, another 50 microns should be subtracted from this value to account for the gasket compression once everything is tightened down. In my case, the calculated clearance value is 1.22 millimeters. With the shims I have on hand, I can make up 1.2 millimeters, which is close enough, especially once the bolts are tightened properly. Before securing the cover onto the housing, I'll add oil to the gears and rotate them a few times to ensure proper lubrication. Next, I'll apply a thin layer of grease to the outer race of the radial bearing. This helps hold the shim stack in place during the assembly. To create a proper seal, a thin layer of liquid sealant is applied to both sides of the gasket. Additionally, the cover's bearing seat is heated to 70 degrees Celsius to allow for easier installation. With the cover in place, the washers and nuts are threaded on and tightened securely. After that, the drain plug is then installed and torqued to 24 Newton meters, followed by the filler plug, which will also be torqued once the gear oil is added. According to the workshop manual, the final drive requires 125 milliliters of SAE 90 gear oil. However, I'll be using 80W90, which will work just fine. The last component to install is the grease nipple, which allows grease to be added to the plunger's bushings and shaft. With the final drive fully assembled, it can now be turned over by hand to confirm smooth operation. Once verified, it's ready to be installed back onto the bike. But since this bike is currently stripped down to the main frame, I'll now shift my focus to rebuilding the 4-speed gearbox, followed by a complete engine rebuild later on. If you enjoyed this video, feel free to hit that like button down below, share this video with others, and don't forget to subscribe to see more content just like this. Thank you so much for watching, and I hope to see you in the next one.